Hello, welcome to TechWeb Dots. Today we are going to discuss what are solid design principles. Okay, so I will explain this solid design principles with very easy code examples. Let's start without wasting time. With what we will learn, what are solid design principles, why we need solid design principles, and how solid works. Okay, and each principle with very easy code example I will try to explain so that you can understand it in a better way. And what are the basic requirements to understand solid is you must be aware about the object oriented programming concepts, okay, with the what are classes, abstraction, or you can say the abstract classes or interfaces. Okay, this is the primary requirement to understand this better. Okay, that will really help. And don't worry about if you don't know about then in the upcoming video session I will explain it in detail. Okay, so what is solid? Solid is promoted by American software engineer Robert C. Martin, okay, many years ago. And if we follow all solid principles, then it will really help us to maintain software app design problems, okay, that we face on real time or in real life while we are developing the software application. Okay, software design is very easy to understand and flexible if we are following the solid design principles. Solid acronym first introduced by Michael Feathers. Okay, so we know very well what is the meaning of solid on the very first screen. So very first principle is single responsibility principle. Okay, and it says that a class should only have a single responsibility. Means if you want to make some changes, so there should be only one reason for change, and that will be an encapsulated class. Okay, so to solve such problems we can create different interfaces, and we can keep it simple and we can keep it smaller as well. So don't worry if it is not clear. I'm going to share a very small and very clean example that will really help you to understand what exactly single responsibility principle is. Okay, so as you can see on the screen on the left hand side, we have an interface, okay, which is iReport. In that I have add entry, at what index I want to do the report entry, and remove entry at what index. Okay, and the third one is save to file. So in out of these three interfaces method, the last one is looks odd. Why? Because the first two method is for tracking, right? We can add the entry, we can remove the entry, right? It is tracking of report. But the third method is save to file, which is for saving the file. It means it's a file saver option. So how we can implement in this scenario, if you are using, if you are not aware about the single responsibility, how we can implement that. So what we will do after, okay, how can we change this code? Actually we will just separate the single responsibility task in one interface, and another one which should be separated we will add it in another interface. So I have divide this interface into two interfaces. One is iReport and second one is iReport server. Okay, in iReport I have added add entry and remove entry of report, and in iReport saver I have added the method which is save to file. Okay, that's how we can maintain the single responsibility. Okay, either we are talking about class or either we are talking about interfaces. Okay, this is one of the example. I am not saying this is the only one way to apply single responsibility, but this is one of them. Okay, so let's move next. So the second one is open close principle. Okay, and what it says, a class or software entities or any other piece of component should be open for extension. Okay, means we can extend that, we can add so many features in that, but close for modification, right? If we have added some base class, so that should not be modified again and again, but we can extend that. Okay, I know it is a little bit theory, but it is very important, and don't worry, I will explain an example just after this. So we can use abstract classes, interfaces as a base class for most common abstract features, and use the separate class for different implementation of abstract methods, and create a child class object and assign to parent. Okay, remember this, create child class object and assign to parent. Let's have a look in a practical. Okay, so on the left hand side you can see in general scenario when we have a class with some properties, okay, which is ID, name, level, working hour and hourly rate, okay, and we have another class which is used for calculation of salary of the employee. So what we are doing there, if you will see, there is a IEnumerable interface, okay, that is responsible for giving all the employee reports. Second is its constructor in which we are initializing the employee reports, okay, so that we can get employees if we are using that class. And the third thing is it is calculate total salary, okay, in that we can see we are total salary and how we can calculate that, just multiplying the hourly rate and working hours, okay, and then we will get the total salary, okay. If this is a normal scenario and there is no problem in this, but what happens in case there is a requirement when we want to give bonus or we want to increase salary on the basis of level, right? So what we can do in the comment that I mentioned, check level and apply bonus if demands came, means if there is a demand we can apply the check, but that if we applied that check over here, that feature over here, so that violates the open close principle, okay, means we are modifying the existing class, right? We are not extending it, okay. So how we can transform this piece of code into a solid code, okay, it means one of the open close principle code, okay. So what we will do, we will create an abstract class which is base salary calculator, okay, and in that we will specify the employee report property, okay, and the second thing is we will specify the base salary calculator method, in that we are initializing the employee report, okay, and the third thing is we are mentioning a abstract method, okay. So what abstract method says that in any of the class, if we are inheriting that base salary calculator class, then we can give the implementation according to our need, okay. So what happened here, you will see in salary, in senior dev salary calculation, we are inheriting base salary calculator, okay, and in that we are override the calculate salary as per our need, okay. We are not dependent and we are not making any changes in the base class. And in the same way you can see in junior devs salary calculator, base salary calculator we are inheriting and applying and overriding the double calculate salary method according to our need, okay. So in this way we are saying we are not modifying the existing class, but we are giving extension of that class, okay, we are extending that. So open for extension but close for modification, that's how we are satisfying it, okay. I hope it is clear to you. Next is Liskov substitution principle, okay. So what this principle says, object in a program should be replaceable with instance of their subtypes, okay, without altering the correctness of that program, okay. If this is not clear at this moment, so don't worry, I will give you example what exactly it is, okay. And base class instance replaced or substitution by its subtype instance with no change in functionality, okay, and it is an extension of the open close principle, okay. Let's have a look on the practical. So if you will see on the left hand side, we have some calculator class, okay, in that we have one property, one constructor in which we are initializing, and one method which is calculate, okay. And if we want to calculate even number sum, then we will simply inherit the sum calculator class, okay, and in that class we are definitely calling the base class as well by passing the numbers object there, and we are giving the new implementation of calculate class, okay. That's how we are using it. And at the time of calling, we are calling the sum calculator class, and creating its instance, okay, and calling sum calculate, okay. And what we are doing, we are creating a even number class which is also inheriting the sum calculator class and passing the number object from there, okay, passing the number, and then we are getting the result. But in this case, if we try to apply the Liskov substitution, means if we try to assign the child class instance into a some calculator instance, that will not be possible. Okay, so for that, how we can convert this code into a Liskov substitution principle? On the right hand side, you can see first we will create a calculator class which will perform the basic operations like calculate method, okay, the one which is abstract, so that we can implement it according to our need in any of the method where we are inheriting calculator class, okay. But which is the abstract class, yes, we can inherit that and apply the implementation according to our need. In the same way, sum calculator, even number sum calculator, in which we are inheriting that class and calculating the number according to our need. So in the final call, you can see we are assigning a sum calculator object in calculator sum object, okay. That is why it is possible. It is because of Liskov substitution principle, okay. So I hope it is clear and it is very easy to understand. You can give example while interview is asking for you to answer, okay. So next is interface segregation principle, okay. So many client specific interface are better than general purpose big fatty interface. It means we don't need to create a interface with so many members, so many methods, and it is better we can create a multiple small interfaces that can be implementable easily and easy to read and understand. Implement only useful interface, not implement a big interface, because broke the big interfaces into useful small interfaces, that will really helpful. And implement multiple interface where required, that will be easy to understand as well. So let's have a look on the practical example. So on the left hand side, you can see there is a print task interface is there, and that contains three methods. One is print content, print copy, and print duplex, okay. So let's suppose we have a HP printer and that has a feature of print content and print duplex only, and that cannot perform print copy. So if we will apply that iPrinter task interface, then forcefully we need to give the implementation of photocopy content as well, and we should return false because that cannot perform that task. It doesn't have that functionality, okay. And in the same way, if we have a second printer which is Canon, and it is also inheriting iPrint task, in that you can see that can only print content, and photocopy content, but cannot work with the duplex content, okay. So how we can solve this problem? So what we will do, we will just create three different interfaces. One is print content, print copy content, and print duplex content, and wherever required we can apply only those smaller interfaces and just implement it. We don't need to forcefully implement the interface which is not required for that printer, okay. That's how it works. So that's how we are implementing this ISP, okay. Let's move next. The last one is dependency inversion principle, okay. What it says, one should depend upon abstractions, not corrections. Details should depend on abstraction, and abstraction should not depend on details, okay. I know this is a bit complex, but I will show you example what I am talking about. But let's read a very meaningful line. High level module should not depend on low level module, okay, and both should depend on abstraction, means there should be a middle layer that will work as a intermediator. Adapter design pattern implement the dependency inversion principle. So adapter design pattern is out of the scope of this video, so I will explain it later. So stay tuned for it and just subscribe it so that you can get the updates the moment I upload the video on that, okay. So for example, implement the repository layer between business layer and data access layer, and let's have a look practically, okay. So let's suppose we are using a business logic layer, okay, and in that we are assigning a object of that, okay, a data layer object of that. And now there is another method in business logic layer which is save object, which is calling the data access layer save detail method. Okay, and finally in data access layer we have a save method. But here you can see the high level module is directly dependent on low level module, which violates the dependency inversion principle. So how we can solve this problem? Just have a look at on the right hand side. In business logic layer we will implement a layer of repository. Okay, and in the constructor of business logic we are initializing the repository layer by passing that object. Okay, and we are also calling the same method of business logic layer, but that is calling the repository layer, not directly the data access layer. Okay, and now we can see a repository layer definitely must have the save method that will be implemented by the data access layer. So that middle layer that we can provide and satisfy the dependency inversion thing. I mean, all these examples that I have given in the solid principles are one of the way to satisfy the solid principle. That is not the one and only way. Okay, so you can implement it according to your need, according to your project situation. Okay, I hope it helps you to understand a bit more what you already know, and stay tuned for the upcoming video, because I am going to explain one by one each principle, okay, in detail. So next video will be on single responsibility principle in detail with example I will show you practically. Okay, so I hope you like the video. Thanks for watching. Have a good day.